Hello and welcome to a brand new series of In Orbit, the podcast where we look at all the exciting things that we're doing in space and how they benefit life down here on planet Earth. Brought to you by the satellite applications Catapult. I'm your host, Dallas Campbell. Very exciting. First episode, we're kicking things off. We're out of the studio. We're in the Catapult, I've got to get this right, In Orbit servicing and manufacturing facility. And today we're going to be looking at all things robots, space robots, with our fantastic panel of experts. Delighted to be joined here today by Jeremy Haddle, who is the robotics lead at the Satellite Applications Catapult. Jeremy, welcome.
Thank you.
Just a little bit about who you are, what you do here in this exciting place.
Yeah, so I'm, as you say, I'm the robotics lead for the Catapult, and this facility is my baby. It's what I look after. It's what we develop. What we do here, particularly in this part of the facility, is we use it to help people test out their in-orbit service and manufacturing technologies. So robots and things that help people do in-orbit service and manufacturing.
We're gonna unpack what that is in a moment. When you say it's your baby, so did you kind of conceive this, as it were?
It sort of.
Did you wake up and go?
Yeah, I was when I joined the Catapult, I was given an idea of what this could look like, and I think my first day was, here's the idea. Off you go, and that was it. So this is kind of all my fault, guys.
Great. Okay. Well, we're gonna explore that in a bit. And sitting next to you, we've got Ellie Alois, who is the robotics system expert at Airbus. Welcome.
So yes, I'm the advanced concept and robotics lead in the UK at Airbus. It is a multidisciplinary team that comprises a whole range of skills to support mission concepts and design future robotic systems for future applications in space.
And of course, everyone knows Airbus because they make airplanes, but Airbus also make spacecraft and other things for the space industry. So welcome, thank you very much. Sitting next to me, we've got Azmat Hossain, Business Development Director at Extends Robotics. So first of all, what's Extends Robotics and what do you do for them?
Thank you for having me. So Extend Robotics, we're saying that we're building the most intuitive human-robot interface. So it's the connection between humans and robots, but it will also enable various other important critical tools such as training robots and managing robots not only in space but also in Earth, and then being able to for humans to connect with robots using complete fully immersive VR.
Just say you are all human, by the way. As far as I can tell so far, no. Well, we should introduce the robot elephant in the room. This one here. Who wants? So what if it just Jeremy? Who? What? Who? Why?
Yeah, so this is Manny.
Manny.
This is Manny, and the robot you can't see behind the cameras is called Sol, because there's a complicated Norse mythology behind this. But the moon always chases the sun, so Manny always chases the Sol. Normally we use Sol as what we call the service or the client, so that's where we're trying to get our equipment to carry out our in-orbit servicing and manufacturing tasks, and Manny has to chase it and then catch up with it. And so on the end of Manny, we've got a dummy spacecraft at the moment, but normally on the end of Manny we would have other robots or sensors or things like that are trying to chase after Sol.
Got it. And was that your idea, the Norse mythology? Did you
have
that sort of cheese dream? You're like, I know, let's go Norse.
Yeah, in a previous company we had Loki, Thor, so we couldn't have Loki and Thor because that's already been taken, so we had to come up with different names. But
I've noticed there's all the offices in this building are all kind of space related. Right, okay, before we go any further, let's just establish where we are. As it's your baby, I think you should do the honours. Where are we in the world? Let's start big. We're at the Westcott Venture Park, which is, what happens there?
So Westcott Venture Park, just outside Aylesbury, it's an old RAF base. For the last 50 or so years, or the first 50 or so years after the Second World War, it was the UK's rocket propulsion facility. Very secretive base.
It's not that secret
it's
now.
It's not that secret now.
There's a lot of signposts.
Great big sign at the top. But prior to that, a very secretive base. Wasn't on any maps. Mobile phones don't work here still.
That's
a legacy from.
Basically, it's kind of like Area 51, but in Oxford, but not really Area 51.
Yeah, not really, no. But there's a lot of rocket propulsion work still done here.
Okay.
So there's a number of companies still on site who carry out rocket propulsion work. and test fire rockets. I noticed as I came in, some of the flags were flying, so somebody might fire a rocket some stage this afternoon in their test facility. So that still happens here. Mostly that's orbital rockets, so they're quite small rockets, rather than very large ones that make lots of big noise and things like that. And there's a lot of other space companies here, including ourselves. And the Catapult here, we operate a number of different buildings. This one, which is our in-orbit servicing manufacturing facility, our Future Networks Development Centre, and our drone port as well.
Right, so that's the phrase we need to look at. In-orbit servicing and manufacturing, IOSM.
Yeah.
I'm really struggling with that. For some reason, I'm struggling with that one. But it's kind of what it says on the tin, in-orbit servicing and manufacturing. And just for those who are listening and aren't watching, let's just sort of describe this room. We're in a very long room. How long is it? Like 25 meters?
It's 27 long.
Oh, that was
Not
my
far off,
guess.
yeah.
There we go. And what is that, 10 meters high, perhaps?
Yeah, it's about that high.
It's black.
Yep.
It's sort of matte blackboard black. Along the wall are rows of cameras. Mm-hmm. And right down the middle, we've got this track with a giant robot arm on it. And attached to the robot arm is what looks like some kind of CubeSat. It's your standard satellite covered in
exactly.
gold foil. And so this is where you test things out. This is where you test... So
this is. This room is black, as you say. It's completely matte black.
Is that to make it look like space? Is that we're in space? Is that the idea?
The reason we make it matte black is because when you're actually in orbit, it's not completely dark.
No,
space is not dark at all. It's quite bright. But we want everything in the room to disappear into the background, which is why it's matte black. So at the moment, you mentioned the cameras. All the cameras are flashing blue lights, most of them. That's just because we've left the lights on. But normally they're all off, so you can't see anything in here. And the robots are black as well, so they disappear into the background.
And why do you need everything to blend in? I mean, this is just a test place, so what's the...
So it's because the only thing we're really interested in is the gold bit on the end of the robots. So the robots in here mostly are pretty dumb, standard, off-the-shelf industrial robots, and we use them in very novel ways.
Yeah.
But they're not the most important part in here. The most important part is the bits that we have on the end of the robots that enable us to carry out servicing and manufacturing in space.
Okay, so that's the location. That's where we are. We're in a long black room. Ellie, just explain to us this robot that's behind us. It's a very large robot arm. What is, with this kind of pretend satellite on the end of it, what is its function like? What is that here to do?
So this facility can be used in a number of ways, and when we're starting developments for robotics, for in-orbit activity like servicing and capture, there's a point up to a point you can do it in your own facilities. Academia will have almost like scaled down version of these facility, and same in some industrial entities. Here we're kind of scaling things up. It's a large rail. It's a large manipulator, and the idea is to use it in a more representative manner using the full-scale system. So where you have a full-scale robotic arm, for example, capturing a representative scaled target or client. So you have that element of scale, and also the way that the client, that box, can actually move in space is of interest, is important to tune some of the algorithms for detection of that from a long distance. And as we get closer and closer, we want to be able to maybe grasp it.
So that specific arm, that's in a way we're kind of not interested in that arm. That arm is there to mimic how a satellite or some kind of space object would behave in microgravity.
Exactly, yeah.
Because I notice it, I mean, IOSM yard, you call it. I mean, clearly not a yard, but it has that sort of, we think of the Mars yard, you might have seen it, sort of JPL or at Stevenage, they've got a Mars yard, I think. So it's that sort of test facility.
Exactly.
Or a neutral buoyancy tank, I guess, might be another.
Yeah, so this is another way of doing neutral buoyancy. We're just using the robots to create that microgravity environment. Neutral buoyancy is a great way of doing things, but it comes with a lot of challenges.
Things get wet.
Things get very wet. And all your robots have to be hardened against the water. So this is just another approach to doing it.
Right. So Ellie, let's say you mentioned that word client. You talked about that satellite as a client. Imagine I'm a client and I've got my satellite. Maybe you could just take us through the process of what testing would look like. So here I am floating in outer space. I want to do something, I want to manufacture or service. What would we see in here?
So, as Jeremy alluded, we have these two manipulators carrying, on the one hand, the servicer in this particular case, and the client, the spacecraft we want to grasp.
So hang on. So the servicer. So that's what people can't see if they're watching this. Behind the camera, there is another golden satellite, but there's a kind of standard robot arm on that.
Correct. So
kind of
on this particular one, we have an Airbus robotic manipulator that we are testing currently. And this is all about emulating these kind of mission concept where we actually grasp a possible client spacecraft, as in a spacecraft we want to grab in the orbit or to grab in service. So this is the place where we can do that. It allows us to exercise it with a realistic setup and realistic hardware.
And I'm looking at that robot arm, and if you imagine what a robot arm looks like, but on the front of it there is a kind of circular thing and a cross. So maybe you could just explain to me what, on the business end of that robot arm, what I'm looking at. How does it work?
So this is our Vispa robotic manipulator produced by Airbus, and it has a sensor suite at the close to where we'll have what we don't see here is a grasping tool,
right?
And we need to provide the robot with the necessary information to track the grasping locations on the client, and for that we have a sensor suite with lights and various other sensors.
So basically, when you're testing, the idea is that your Airbus robot arm will come and grapple with our satellite and do whatever needs to be done.
Correct.
And this one behind me will behave as if it was in space, and so you can work out what needs to be done.
Exactly.
Yeah, and I suppose we're fairly used to robots in space. I mean, we think about the International Space Station, things like the Canadarm is used for grappling incoming spacecraft and bringing it closer to the station, for example. And I think there's a kind of a sort of humanoid sort of robot on the International Space Station. I'm not quite sure what it does. It looks quite good. But the idea of kind of robotics in space is not a particularly new thing, certainly on the space station.
No, certainly on the space station it's not, and most of the space station was built with a robotic arm attached to the shuttle originally.
Yeah.
I think what's different certainly with Vispa and similar arms now is they are smaller by necessity, not just for launch rate but also just for the task they're carrying out. And the aim is to make them less complex. So to operate the Canadarm is a really complicated task on the ISS. To be able to operate these kind of robots autonomously, that's the ultimate aim. In orbit away from a manned spacecraft is the ultimate aim. And so, yeah, these robots are much smaller, much cheaper, ultimately. That's got to be the way we go forward to make this a realistic thing.
Asmat, let's bring you in here as the sort of business mind here. What are the benefits of being able to manufacture and service objects in space?
Well, we're going to the next level of, I would say, evolution in space, and when that comes in with a lot of different smaller companies and a lot of new ideas that are being generated, which is how not only with space but other sectors are also developing. There's a host of really evolutionary technologies that are being developed. So this will enable us. Humans to go out in space and do things which was not possible before, and we could utilize the sort of advancement could bring in other benefits which was not available before, such as lower cost, better telecommunications, better more advanced things.
Yeah. I suppose we should just establish that, I mean, the way things work at the moment, we send something up into space, a satellite, and once it's up there's not a lot you can do with it. Once it's there, it either kind of works or it doesn't work, and once it comes to the end of its life, it just stays there forever or burns up in the atmosphere. But suddenly, having stuff like this presumably means that it's going to open up a whole new realm of being able to fix things and make things. And
Yeah, so we are going to the next level, which is like having this sort of arm or this sort of technology, which can open up a lot more. I would say an agile way of doing things.
Like what kind of stuff? What kind of stuff would this stuff be able to do? Have you got any examples of things that we could make or?
Yeah. So, I mean, spaces will be of course, the extension of the Earth and the next level. So as we move on, and we have limitations in the Earth in terms of space and in terms of how habitable areas. So we can go into space and do things. So manufacture parts in space, where maybe even on satellites, some of these we can be used to habitate the moon or other planets. And for that, we need to manufacture parts. We need to manufacture a host of things, and this could be done in space itself using robotics. But as mentioned before, it was not possible because of the limitations in technologies. But now, because of these advancements, we are going to the next level.
So is the central idea of this, we're limited in terms of the size of things we can put up into orbit because of the shape of rockets. You can put, a rocket fairing will only hold so much, and yes, you can fold things up. But suddenly having manipulators in space, robot arms, we can build things in orbit. Is that the main goal?
Yeah, I think that's one of the main goals behind this. Is we're talking in mid-March. Starship has just had its third launch. It was relatively successful, even though the vehicles didn't come back. Even with Starship, we're still limited by what we can launch into space. So having these kind of arms enables us to build so much bigger things.
So this is actually, we don't need bigger rockets necessarily. We just need smarter robots that can build things in orbit.
Yeah.
I mean, I think of things like, we talk a lot about big solar panels in space, that type of thing.
Yeah.
If we're going to have that, obviously they're going to be very, very large. It'd be impossible to launch a huge solar panel into space.
But once you've got that big thing into space, as you say, that's it. You've launched it into space and it's there, and you can't really do much about it.
Yeah.
These manipulators also give you the ability to go up and then to service those things, to repair bits, to refuel them, to change modules as you need to. So they're opening up a whole new commercial opportunity for a huge range of companies.
Yeah. I mean, I think about servicing things in space. We had, you mentioned the space shuttle and the arm, and of course, fixing the Hubble Space Telescope involves humans going up there with spanners and what have you to do it. So this is, in a way, going to replace all that.
Yeah, and it will. And the thing we need to remember about Hubble was designed for this. Most of the things that we're looking at the moment have never been designed to be serviced or repaired. So Ellie will have to put a lot of clever things, or almost AI, into the robot to enable him to be able to go and service something that hasn't been designed for it and was last seen on the launch pad.
But presumably, once this kind of technology is working, as people design satellites, they will be designed to be fixed with this kind of technology in mind.
Exactly. I think we're in a phase right now where, at a stage where, as you said before, it's going to fire and forget. It's there. And right now we're looking at what can we do and how can we manage these platforms as they are today, and deorbiting may be one of the options for them at the end of their lives, but also what are the options to service them, how to upgrade some of their payload, how to refuel them and extend their lifetime. And as we're kind of doing that, we're going to kind of evolve towards a more kind of standardized and development of standards for these modules that we can exchange, leading us to the point where it's very likely that we'll be able to send flat-packed spacecraft and assemble them in space with space factories. That means that we're saving some launch costs, we're saving some mass, and it will make things a little bit more economic and cheaper access to space.
Space IKEA.
Space IKEA.
Space IKEA is the goal. That's interesting. I mean, I suppose as our activities in space increase, this idea of the circular economy comes into play, where things have to ultimately pay for themselves and become profitable.
Yes, I think where we kind of evolve, moving our visions, our view of spacecraft to more of a kind of cradle to grave kind of things, and understanding the impact of the design elements, the operation, the launch operation, and then what happens at the end of that mission. And increasingly, we're trying to see how we can maybe recycle it in the future, how we could actually revalorize it.
Yeah. So recycling, I suppose, is the other thing. So manufacturing, that's one thing. Servicing, that makes sense. Recycling. So normally satellites, you chuck them up there and they stay up there forever, as I mentioned. But would the idea be that you could use technology like this to bring it back and reuse the materials of that satellite back on Earth? Is that?
Absolutely. I think there's lots of debris or some of that could be recycled. And we could operate and the robots to do that recycling, either to be manufactured into remanufactured into usual things on space, or we could bring that back on Earth in some way to be reused. Yeah.
Is that feasible? I mean, we talk a lot about clearing up low Earth orbit and space junk, and there's been all sorts of exciting methods with harpoons and nets and all sorts of things. Is this going to be, do you think, a solution to space junk? Well, firstly, how important is clearing up space junk? Is it something we need to be thinking about now?
Yeah,
with seriousness.
It is something we need to be thinking about now. It's kind of, you can almost equate it to plastics in the oceans. It's nowhere near as bad as plastics in the oceans. But if we don't tackle it now,
then it
could be. So you mentioned harpoons. So harpoon is one way to capture a spacecraft. Chances are when you fire the harpoon into that spacecraft, you get lots of extra smaller bits of debris that come off it.
This is the Kessler syndrome, I think it's called.
Exactly.
Which sounds very sci-fi, but this idea that suddenly you get this exponential amount of stuff flying around at 25,000 kilometers an hour.
So if anybody's watching it or listening has watched Gravity, that's the Sandra Bullock, not Tom Hanks, George Clooney film.
George Clooney.
That's the Kessler syndrome.
Yeah.
You get to a point where there's so much debris that it becomes almost impossible to operate in space.
Yeah.
And some people say we're kind of close to it. Some people say it's already happened. I think we're probably not there, but it's a reality.
Do we know how many objects there are in low Earth orbit at the moment?
Yes.
People keep telling me and I forget. The number changes.
So ESA do an annual survey of this, and there's around about 8,000-ish satellites that we know of in orbit, and about 6,000 of those are still operating.
Okay.
You then go down to smaller objects, and you can count probably about up to around 1 million objects that are up to about 10 centimeters.
Yeah.
Once you go below that, it becomes really hard to track it, and the number of items there just exponentially increases, and it's estimated to be over 1 million items. It could even be near 100 million items when you get really small, but nobody's really sure. I
think that's the thing. It does seem to be quite sort of Wild West up there in terms of nobody's quite knows what side of the road we drive on in low Earth orbit, and sort of sorting out the kind of rules of the road seem to be an increasingly important thing, given that all kind of civilization now is pretty much dependent on what we do in space, even though people perhaps don't realize it.
Yeah, so there is a lot of the impact that space could make on Earth itself, and whether we realize it or not. So this, of course, there's the data being provided from space, and there's interconnection that provided by satellites and all sorts of things that could be impact. Right.
So we've got this great technology, robot arms that can actually now interact with satellites, fix them, move them around, presumably service them. We can build things. Just give us a sense of some of the sort of the companies that are thinking about this with your business hat on. Who are you talking to? What sorts of people?
So, in terms of space, we would like big primes like Airbus and all the other big companies to adopt this robotics, and of course the new age robotics that's coming up, which is more smarter and takes to the next level of robots that we're trying to create. a sort of like modular system of robotics, which will make it more affordable for companies, make it more easier to adopt.
What do you mean by modular robots?
A modular robot will mean that it will have a standard interface. It will have the ability for people to connect and train them. It will be able to do very complicated things, not just simple one pick and place of processes, but it will have the adaptability to manage situations and also to be able to train remotely from anywhere in the world. Training the robots would be integral for the journey. Yeah.
When you say training the robots, what does that mean? Because I'm sort of just imagining a robot arm that you can kind of, I don't know, control with a joystick on Earth. But are you sort of implying that, you know, these robots will have a degree of autonomy where they can sort of fly around and...
Yes, I think what we can see, for example, is that depending on the place and depending on the task, you have a whole spectrum of operation principles that you can use. So, for example, for rovers on the Moon and Mars, you have to have a level of autonomy, but you also want to be able to push a big red button. So you can go for the fully autonomous, and this is really the target. It's almost like intent-based actions where the operator just tells the robot to do something, and
a bit like
the robot
HAL
goes
9000 in 2001. That sort of level of autonomy.
Yes, that kind of level of autonomy. And then you kind of go back to one level up, one level down, where you have a little bit more involvement from the operator because maybe you're closer. You can have supervised teleoperations where you have some onboard system that will prevent an operator from doing something he shouldn't. And then you got the fully teleoperated scenario, and this is, for example, where Azmat's software comes in, where it's all about the operation real time of a robotic system, or being able to train it to perform specific actions.
I mean, it seems quite. It's an exciting technology. I'm just interested in sort of where we are with it. Like, how long before this type of technology is that we're actually going to see and is actually going to be used?
Well, if you see autonomous driving, it's taking a lot of testing and because there's a huge amount of data required, and driving is just a few variables. You have the road, and then you have the other cars, and you have a map. But think about and if you're doing a task by a robot, then it will need lots of data, and this data will have to come from somewhere. I mean, we can do simulations. Researchers can do simulations, but how much realistic that can be is there's limitations to that. So we're trying to create a system which will be like a step-by-step process of training. So in the initial stages, it will be like a one operator operating one robot or two robots and doing things, helping them out. If the robot gets stuck or if it gets lost in space, it could get lost. The control of that robot
it's pretty
remotely.
Big space.
Yeah, that's the thing. And especially in space, there are so many variables. It's quite impossible to plan everything.
Hence, Jeremy, why this place is so important.
Yeah.
I mean, is it, when I think of things like flight simulators, pilots can get trained in a flight simulator, and flight simulators are so good that you can go straight from the simulator, straight into the plane, and fly a plane load of passengers to wherever you've got to go. Is that the aim for here? I'd like to just explore a little bit more about the room we're in at the moment and what it's capable of.
Yes, so that would be one of the outcomes for the facility. And the facility, the room we're sitting in is the first iteration of this. There's very few of these in the world. I mean, there's one in the US, there's one in Germany, and there's one in Spain. And so there aren't many of these around. And all of us are learning how to do that.
And do you all talk to each other? Is there a degree of competition?
There's a bit of competition, but there's also a bit of collaboration going on between us. And we're all learning how to do this. And we're in the process of upgrading this facility with more complex dynamics in the robotics, more cameras, more tracking, all this kind of stuff. But yeah, ultimately, you would be able to come in here. You'd be able to simulate your mission completely. We haven't gone to there today, but we've got a control room upstairs where we can control this facility. It looks like a standard control room. That's what it's designed to look like. So yeah, you can control it from there. You can train your operators. You can understand how this stuff works, and ultimately get to a stage where from what we would term as a space technology, you're at TRL6. And TRL6 means you're in a representative environment and you're testing.
What's it called? TRL?
Yeah, technology readiness levels. They came from from the shuttle era.
Yeah.
And TRL1, quite simply, is I've got an idea that I've written on the back of an envelope. And TRL9 is I'm launching space shuttles over and over again. And TRL6 is testing all of that in a representative environment. That's where this is aimed at. That also means we've got to validate how it's operated and by who. So that's the aim for this whole facility.
And are you busy at the moment? I mean, have you got lots of people coming in testing stuff? I'm interested in kind of, where we are with that. Are people sort of clamoring to get in here to test stuff out?
Yes, they are. Yeah, we have a number of campaigns. We can't talk about all of them, but we've got a number of what we call
Tell
campaigns.
Tell us the secret stuff.
Yeah, I can't because people like Ellie will shout at me and then not come and use it. So we have lots of campaigns planned over the rest of this year, and we're also, like I say, we're also upgrading the facility, so that makes it a very exciting time for us with lots of new technology coming in. And if we come back in a year's time, it won't look like this.
What will it look like?
Well, so to start with, very simply, the robots will be the other way around.
Right, okay.
We'll have. We haven't talked about it, but at the end of the room, I don't know if it's in shot, but there's a big light. That's going to be. We're going to be able to move that around dynamically. So the aim of that is to simulate the sun as it affects sensors and comes around.
Okay.
So we'll be able to move that automatically.
So basically, well, actually, that's interesting. So you've got a sun there. So basically, this is a kind of we're just a mini solar system, ish, sort of, but 25 meters long.
Yeah. But it is 25 meters long. That's tiny space times.
Yeah.
We talk about coming close to a satellite and docking towards it. That kind of technique starts at 110 kilometers away. And we've got 25, 27 meters to play with. So we do tend to scale things down in here quite a lot. But you still get the same approach.
I suppose, I think about when you break down in a car and you need the RAC, it's all quite simple. You call the RAC or the AA and they come and stop and the man gets out and they get a spanner. Doing things in space, I'm assuming, is difficult, given that things are moving very, very quickly and things behave very, very differently as they do on Earth. So maybe we should talk about just the sort of challenges involved and, when it comes to the physics of all of this. So, Ellie, you can...
So, in terms of... Yes, I'm just rebound on your RAC point. So we are expecting to build larger infrastructures in space. We're talking about antennas, maybe 100 meters across, or maybe space-based solar power to beam down power from space. That will be like a kilometer across. What we can expect is probably hundreds of robotics agents working really hard to build this thing. And I think there's one certainty we can have is that robotics will fail at some point.
Surely not.
So
there's one thing I've learned about new technologies is at some point you have to turn it off and turn it on again.
That might work. Sometimes it doesn't.
Yeah.
So what we're looking at is how we can actually make it economically viable and try to move away from building a big monolithic system, but making things that can almost like repair themselves. So
how do you mean repair themselves?
So if we take the example of a space factory, it's very likely that you'll have two manipulators working in sync to build something. And through some machine learning or AI elements, we can do predictive maintenance of these robotics systems and try to see that something is not quite right with one of these manipulators. And the other manipulator will be able to actually remove a failing robotic joint from the other one and replace it with a new one. So that means that economically, you're not losing your whole system, and you can just bring spare parts. And that really enables, that really changes the kind of the economics of building these large structures in space, because you don't care so much about one element failing.
I mean, the way you're talking, it does seem like it's going to be quite a radical step change in terms of the objects that are going to be in space from, we've been talking, satellites are getting smaller and smaller and cheaper to launch, but suddenly the idea that we can actually IKEA-style build giant, kilometer.
Yeah, I think there's a lot of around these topics, and again, it's all about addressing some sustainability elements where a single platform can be shared with multiple payloads, and you can actually swap them around over the course of their lifetime.
And will we be able to move things around in space? These kind of robot arms, these manipulators, will we be able to sort of use them as sort of tow trucks and sort of move things to different orbits or change the positions of things?
Yes, there's an element of that, because once you have a need to get all these different feedstock and parts up to various orbits, we're very likely to see some sort of logistics between a lower orbit to a higher orbit. And I think this is really an ecosystem that's developing right now. And at all stages, between the logistics, the robotics, the AI, the control, all of that is actually maturing and are key building blocks to enable these visions.
I mean, we've seen this great sort of revolution in how space has changed, really, the way that we do anything on planet Earth. I'm just imagining, if we sort of fast forward 10 years in the future, what kind of things we'll be seeing in space. Will we be seeing these large structures being able to be built, do you think, in 10 years, or is that too optimistic? I'm trying to get a bit of a time frame on all of this.
I don't think that's optimistic at all. Right now, sitting on the ISS, there are 2 robot arms who have been carrying out simulated assembly tasks from a company called Gittite, and it's the videos show them operating at 75 times speed, just because nobody's got the time to sit there for the length of time it takes.
Somebody will sit and watch that in real time.
But the reality is, if that's there now, and it might be very slow, and it might not be absolutely finalized, it might not be the right things, but if we can do that now on the space station, in 10 years' time, definitely we'll be building bigger structures, definitely we'll be servicing satellites. And we might be doing garbage collection in space and recycling. I think that's probably a little bit further off, but definitely that's coming.
Asma, I'm interested in where the UK is placed in all of this. A lot of people who aren't involved in the space industry, they might see the odd Elon Musk Starship launch, and that's kind of where space is for them. But where does the UK sit in all of this, and where are we placed, do you think?
I think UK is a very great place in terms of space. The thing that's happening in UK is a very close collaboration between researchers, academics, and industrial people. So everyone is working together very closely, and we have these great centers like the satellite applications, Catapult, and also there are other centers, similar centers, who are working with each other, and that's very critical in terms of creating these new technologies and helping larger companies, also smaller companies like ourselves, who have like ideas and how to test these ideas, how to build them into and place them on space for real world applications. So I think that sort of ecosystem the UK is developing, and I'm not sure, I can't compare between different countries, but I think overall the UK is doing really well in this, and hopefully that we will be doing much more.
Yeah. Jeremy, are you excited about where the UK is at the moment? With
I am. I think we've got some really unique capabilities. We've got some really good robotics capabilities, not necessarily in the space industry, but we're very used to putting robots in difficult and challenging places.
Are you reaching out to other bits of the robotics world and saying, well, come and talk to us?
Yeah, absolutely.
Can we borrow this? And
absolutely. So like I said, we've got really good expertise in putting robots into nuclear power plants, which are very challenging places. Yes. You're never going back to see that robot again. The same with the offshore industry. So those industries are very relevant and interesting, and we're talking to those. And then we've got a lot of big companies like Airbus, and also smaller startups and SMEs like Extend in the ecosystem. And we've all got this vision of this is a commercial opportunity for the UK. So it's really exciting, and it's space and it's robots. Space is cool, robots are cool.
Space and it's robot, and it pays for itself, presumably. I mean, that's the thing, is that ultimately, presumably, all this comes down to things being commercially viable.
Yeah.
And this is obviously, well, am I right in thinking this is a way to really open up space and make it really commercially viable?
And that's the key thing about this is space is becoming a commercial enterprise. It's no longer just about the exploration and understanding what's out there. It's about how do we use those resources? How do we use those resources sustainably? But how do we also make make money out of it, essentially. How is it a commercial opportunity for us? And the UK is well placed to do it, and I think we're on the right path to really benefit.
Thank you so much. That was absolutely fascinating. Thank you. And thank you for letting us into your
No problem.
Your mini solar system. And thank you very much to
Manny.
Manny. I knew I'd forget Manny's name. Anyway, a pleasure. Thank you very much. Thank you.